which medium does a wave travel through the fastest? A solid, a liquid, or a gas? A solid, right? Now, again, don't get that confused with clarity, right? Because remember, we said that you can hear me very clearly because my sound waves are traveling through the air to your ear. But my sound waves would travel faster through the water, but you wouldn't hear me as well through the water. So don't confuse clarity with speed, okay? All right. Well, now we're getting into another type A wave, all right? So now what makes this wave very unique is the fact that we've been talking about what waves need to get from one side to the other side, and that's a medium. Well, we're going to talk about electromagnetic waves because electromagnetic waves, they are waves that don't need a medium, all right? I do. You sure you want to borrow it from me? Okay, here you go. So, in this scenario right here, all right, transverse waves are made by electric and magnetic fields, all right? Electromagnetic waves are made by electric fields and by magnetic fields. Hence the name electric and magnetic electromagnet. All right, electromagnetic waves are waves that are made by electric fields, which we haven't talked about, which that's what the next unit will be. But this is kind of, we don't care so much about the electric field, magnetic field issue. We just want to make sure we understand that this is the wave component to it. And these waves are produced, all right, by vibrations, okay, just like sound waves. But these are going to be, these waves right here, because it says transverse waves, these waves are going to have crest and troughs. Crest and troughs, all right? They will not have the rarefactions and compressions, all right? Now, if anything here, that's probably your most important bullet point, meaning the electromagnetic wave definition obviously is important, so you know what it is, but the key here is this. In an electromagnetic wave, it's a transverse wave. So, again, an electromagnetic wave is going to look like the waves we've been quizzed on every day last week, all right, with the highs and the lows and all that stuff, the amplitude and the crests and the troughs and the wave wavelengths. But the difference between the wave today from all the waves that we talked about last week is that the waves today, they can travel with a medium, like all the other ones, or they can travel without a medium. They don't need to have something to travel through. They can travel through nothing. And we wrote it down last week. What do we call it when there is no medium in the environment? What do we call that when there's no medium? And I know some of you are writing, but my devil's over there is looking it up. Let me know when you find it. What do we call it when there is no medium for a wave to travel through? I gave you an example being space. Because I said in space you would see the explosion, but you would never hear the explosion. A vacuum, because space is a vacuum. There is no medium. There is no air. All right. There is no material for a wave to travel through. So that's why sound cannot travel in space. But light can travel in space. That's how we get the light from the sun, because the sun is out there in space, and so are we. But there's a big space between the sun and the planet, and the planet Earth. But the light from the sun can reach the Earth because light waves, which this right here, are light waves. Okay? So if you had to kind of get something to understand, electromagnetic waves, those are light waves. Go ahead, Victor, you ain't gonna bother me. All right? And sound waves are the slinkies. Sound waves are the longitudinal waves. So light waves have the crest and the troughs. Sound waves, they have the compressions and the rarefactions because they're the ones that look like the slinkies. All right? But remember, the most important point of this slide is the fact that electromagnetic waves, they don't need a medium. They can travel from point A to point B without having something to carry them there. Okay? Now, another name for an electromagnetic radiation is electromagnetic wave is radiation. So sometimes you'll hear this word right there, and you'll sometimes hear it called an electromagnetic wave, but basically it's the same thing. Matter of fact, we already heard the word radiation. Where did we hear about radiation?
Another way to transfer energy.
What kind?
Like light.
No. Sort of. Heat, right? That was our 3 types of heat transfer. Remember we said that, what were the 3 types of heat transfer?
Convection, conduction.
That's right. So we had conduction, convection, and radiation, right? And radiation, we said, was basically is light, when it gets absorbed, it's going to change into heat, right? That's why if you put your hand near a light bulb, your hand feels warm, and that's because the light from the light bulb hits your hand absorbs that light, and then once it absorbs the light, it changes over into heat. Well, again, that's why? Because again, electromagnetic waves are traveling through the air to your hand. But those electromagnetic waves, they can travel through nothing. They can travel through a vacuum and still get to you. So that's, again, an electromagnetic wave here. So now the big idea here, though, is this. All right, you have a diagram, okay? So this is where we're going to start to turn our attention. So once you have kind of written down the screen, start looking at that diagram, which I will have on the next screen. But you need to start kind of getting an idea of some of the words that are on there. But there are going to be a couple of things that I need you to know, because there are certain kinds of questions they're going to talk about. And when you look at the diagram, the question may refer to something that is not on the diagram, that's not obvious on the diagram, but it is on the diagram. So it's like there's something that you got to know is there, even though it doesn't tell you that it's there. So you have to know how to look for it. All right, that's why I said the connection is, you got to remember the connection between wavelength and frequency. Okay, you got to make sure you know the connection between wavelength and frequency. So while you wait for your last couple of classmates to finish up this screen, you may want to go back and look at that connection again in case you forgot it since like 15 minutes ago. All right, what is that connection between wavelength and frequency? Okay, the wavelength connection. All right, are we good? All right, so if you're looking at your diagram at the top right, notice again it is called the electromagnetic spectrum. Okay, the electromagnetic spectrum, which is what we're going to see. Remember we said that light can bend? And remember we talked about the rainbow? When you bend the light, sometimes you can bend the light into its different colors that make up light. Well, that's what you kind of see here is that spectrum, and that's what they're showing you in these words. All right, so let me erase here. And so here's the diagram that we're looking at. All right, but now go ahead and write down, well, actually, you have a diagram. So what's more important is this. It's more important that you write this here and this here. All right, the other part is actually in your diagram, so you don't have to have it in your notes, because remember, you'll have the diagram whenever you take a test. So the electromagnetic spectrum is the full range, all right, of frequencies of the electromagnetic radiation. So the spectrum is just the range. So the electromagnetic waves spectrum begins all the way from microwaves on the far left side of your diagram, and it goes all the way to the right side of your diagram where you have gamma rays. All right, so it starts over here, all right, and it goes all the way clear over to the gamma rays. And so what we need to do is we need to get a full understanding of what that diagram is saying. But that's what a spectrum is. A spectrum is just a fancy word for a wide range. So this like if we talk about the light spectrum, the light spectrum would be Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. So that would be the spectrum to light. But the electromagnetic spectrum is a little bit wider than that. It starts off at radio waves, and then it ends at gamma rays. So that's kind of what we're going to talk about here in your diagram. But again, there are going to be two words that we're going to focus on, and there is one connection that we got to remember. So 2 words to focus, 1 connection to remember. And then from here, it becomes a skill. So this is why I said, like this diagram, if you could look at that diagram all day and not know how to really use it. But once you use it, you realize it's really, really simple. Are we good? Anybody need 10 more seconds? If you do, say 10. All righty. 10 more seconds to use. Now, I want you to, there are a lot of arrows on that diagram, but if you're looking at the diagram on the board or the one on your paper, like I'm going to have it on my board, but just realize it's the same one on your paper. I want you to look at the bigger, blacker arrows. All right, so find the bigger, blacker arrows and look at what those arrows represent. Okay, that's your starting point. For us to understand the diagram, you got to understand the starting point. The starting point is those bigger, blacker arrows and what they represent. So, with that in mind, Coburn, tell me what you think they represent. Okay, so they represent longer and shorter wavelengths, so that means they represent wavelengths, right? Now, there was a connection I told you to remember. Who remembers the connection that isn't in the back row? What was the connection I said to remember if you're not in the back row? You're in the back row. I know, it's driving you crazy.
I know it, man. Let me just answer it.
No, other people can answer too. It's amazing how when I called on people, like nobody said anything for like 15 seconds. Then I just said somebody's name and they answered it. Like, why don't you just answer the question out loud then? It's not illegal. All right, so again, what's the connection I said to remember?
The longer the wave, the lower the frequency.
The longer the wavelength, the lower the frequency. All right, that was one connection. What was the opposite, or what was the other connection? I don't want to say opposite. What was the other connection? It's still dealing with those things. He said the longer the wavelength, the lower the frequency. Or you can remember it as what? Say what? The shorter the wavelength, the higher the frequency. Okay? So those are the two connections. Bigger the wavelength, lower the frequency. Shorter the wavelength, higher the frequency. Everybody got it? So, now what I'm going to do is I'm going to flip the switches. Hopefully that will make it show up better on the video. But if not, there's a big white glare, but I think we'll be okay. So now what we're going to do here is we're taking a look at this same diagram. Now, here's the thing. Okay? Right here, it says longer wavelength. All right? And it's pointing to the left. Okay? So I'm going to literally treat you, not that I'm trying to say you're slow, but I'm going to treat you like you're slow so that we go little by little and step by step so you understand exactly what we're talking about. Longer the wavelength points to the left. If you look at this arrow over here, shorter the wavelength going to the right. Okay? So that means, again, remember we talked about waves when we're doing this right here, right? Here's the transverse wave, right? Where are the bigger wavelengths located at? On what side of my wave? On the left. Where are my smaller wavelengths at? On the right. Okay, so that's what this diagram is saying. It's saying that the shorter wavelengths are on the right side, bigger wavelengths are on the left side. Okay, that's what those arrows mean. Because that's also going to relate down to frequency. Mr. Simon? I have him just signing today. I just have him signing. Yeah, for today I'm good. But thank you. Okay. Thanks. Bye-bye. All right. So, okay, you don't need, what I circle, you don't need to circle. Now I'm circling so you know what to look at. Okay, so let me start off simple. I've circled two words on that diagram. Circled out two words on that diagram. Okay, so here's my question. My question is, of those two words, which one of those has the smaller wavelength? Don't answer it out loud. I'm going to JLo. Ultraviolet. All right, that is correct. Okay, ultraviolet has a smaller wavelength because, again, remember, longer wavelengths are to the left side, shorter wavelengths are to the right. So out of these two words, the one that is more to the right is going to have the shorter wavelength. The one that is more to the left is going to have the bigger wavelength. So that's kind of all you're having to do. So again, it's a skill, not a difficult one, but again, you kind of have to remember what we're looking at here. Now, this isn't the only part of the thing that we got to remember. There's more to it because, again, we have to get to that connection point. But let's just make sure we start off here, making sure everybody gets a shot. All right, so here we're going to go microwaves, infrared. All right, microwaves and infrared. All right, so with that in mind right there, let me throw that one over to Mahomes. Which one of those two, out of those two that I've circled, which one of those has a longer wavelength? Microwaves, all right. So there are those. Now we're going to go right there. I've circled two words. All right, so everybody see the two words that I've circled? All right, Kevin, out of the two words that I have circled, which one of those has a longer wavelength?
Gamma rays.
Gamma rays, all right. So do you see the word longer wavelength on the screen anywhere? You don't? Not even there?
Right here.
Okay. Which way is it pointing? Left. So whichever one is pointing, the one that's more left is the one that's going to have longer wavelength. Which word did I circle as more to the left?
X-rays.
X-rays. So that's the one that's got longer wavelength. All right. Are you good with that? Okay. Because remember, right now what we're trying to do is we're trying to make sure we understand the two bold arrows that are on your diagram, because these are on your diagram. All right. Eventually, we're going to get to a question that's not on the diagram. You're going to have to know how to use it. All right. Infrared, ultraviolet. Okay, those are the two words that I have circled right there. Infrared and ultraviolet. All right. Victor, do you see the two words? All right, great. So my question here is this. Out of those two, which one of those has the smaller wavelength?
Ultraviolet.
Ultraviolet, that is correct. All right, so ultraviolet's got the smaller wavelength. All right. Let's go here to microwaves and X-rays. Microwaves and X-rays. All right. Let's see. Jasmine, see the two words that I have circled? All right. Out of those two words, which one of those has the shorter wavelength? X-rays. All right, that is correct. All right, so let's go here. All right, Nate, see the two words that I've circled? Which one of those has the longer wavelength?
Wouldn't it be radio waves?
I asked you first.
Huh?
I asked you first. You said, wouldn't it be?
Radio waves.
Radio waves, all right, there you go. He's going radio waves, and that is correct. All right. All right, now, let's go and do this one here. We're going orange and blue. Orange and blue, all right? So for that one there, Alondra, which one of those has the shorter wavelength? Blue, all right, that is correct. That is correct. So notice now, it's the same pattern. All right, now I'm going to go yellow and violet. Yellow and violet. So for that one right there, Raina, which one of those has the longer wavelength? Longer. Yellow. All right. So now, if we go here, now I'm going to throw it over here to, let's go red, infrared. All right, red and infrared. Those are the two words that I have circled right there. All right, everybody sees them? All right, Donovan, which one of those there has the longer wavelength?
Infrared? No. Red. Yeah, red.
Have you given an answer? I couldn't tell.
Yeah, red.
Oh, what'd you say?
I said red.
You said red. Okay, I thought you said, yeah, right. Like, I just heard that. So, you saying red?
Yes.
Okay, red. All right, he kind of hesitated there, though. So, Zyquez, you agree with that or you disagree with that? Longer wavelength, yes. You going with that? All right. Now, you ready? Here, let me tell you why his answer is wrong. Okay, let me tell you why his answer is wrong. It's not that obvious until you know to look for it. See those dotted lines right there? All of this stuff here, all of these colors are right in here. They just kind of brought them out and then spread them out bigger just so you can see it better. All right? So really, in reality, it's your colors of the rainbow. Your colors of the rainbow are actually right in here in between that. Okay? That's where it actually fits. But they've just kind of zoomed in on the colors and just separated it out here at the bottom. So if you look at it, right? So we had red and infrared circled. Well, here's where red actually is. And here's where infrared is. So which one of those has a longer wavelength? Infrared. Okay, so that's the way you actually look at it when you get into the colors there. So that's one thing that most people tend to kind of get confused with. So that's why I wanted to make sure that you understood that. All right. So let's give another one here. So everybody kind of familiar with where that goes. All right, let me throw it over here to yellow. All right, and infrared. All right, yellow and infrared. So my question now becomes Jordan, Which one of those has a higher has a shorter wavelength?
Yellow.
Yellow. All right, that is correct. All right, Eric, which one of those? You're familiar with the words now because we've gone through all of them. So now I can just say words. I don't have to go ahead and circle them. All right, Eric, blue and green. Which one has a shorter wavelength? Blue. All right, Kevin, orange and violet. Which one of those has a longer wavelength? Orange. All right. Alondra, since I'm boring you, violet and ultraviolet. Which one of those has a shorter wavelength? Ultraviolet. All right. Everybody kind of getting the handle here of the wavelength stuff? Okay, great. Because most of the time the question they're going to ask you isn't about which one has a bigger or shorter wavelength. Most of the time the question they're going to ask you is frequency. All right. So here's where we got to remember that connection again. So again, what is the connection between wavelength and frequency? Mahomes, tell me. Okay, and what's the other connection? Anybody besides Mahomes? How we don't know this in our brain right now, I don't know. All right, my devil? Say again? Okay, the longer the wavelength, the lower the frequency. All right, so here's my point. The only thing this diagram tells you is about wavelength, right? So we know that our wavelengths get bigger as you go to your left. You know that your wavelengths get shorter as they go to the right. So the question now here is this: where do you find your higher frequencies? Where do you find your higher frequencies?
Pardon the interruption. At this time, will Ms. Courtwright's Spanish class and Spanish club students participating in the Grow local event this morning report to the PAC at this time. Teachers, please refer to the participation roster that Ms. Courtwright sent to the staff.
All right.
It's got like an opposite relationship instead of the longer.
Hold on, what did I just say? What did I just say? I don't really remember what I just said. I got distracted by the video.
Which one's gonna have the
Basically, how do we identify frequency?
well,
Now, didn't I ask a question? Did I say like what side is the higher frequency going to be on?
Yeah.
Okay, yeah, that's what I want to know.
oh,
Where's your higher frequency going to be?
shorter.
Oh, right, it's a left-right answer.
On the right.
Right.
The right side. Okay, like that's the whole issue right here. If they ask you higher frequency, in other words, Zyquez, do you see the word frequency anywhere on the diagram? No. So if they ask you a question that says something about frequency, you might look at this diagram and say, well, how am I supposed to know that? They don't tell me anything about frequency in this diagram. But they do. It's just that you have to remember the connection here of frequency. If it has a shorter wavelength, then what is that going to be for frequency? Higher frequency. If it has a longer wavelength, then what does that mean for frequency? Lower frequency, okay? So again, the whole issue here, which I would suggest that you probably don't write down in your reference sheet, is that where it says shorter wavelength, it's higher frequency. The reason why I say I wouldn't write it on your sheet is because if you write it on your sheet, you're not going to remember it, and then when you get mine on the test day, mine won't have that higher frequency written down. But what I'm trying to get you to see here is I'm trying to get you to see that this is the relationship that we need to understand between wavelength and frequency, and that is the longer the wavelength, the lower the frequency, the shorter the wavelength, the higher the frequency. So for a couple of these questions, I'm going to go ahead and leave that up there so that some of you can connect dots, but after a couple of questions, then I'm going to erase it to see who can remember this in your brain. All right, so we're familiar with the word, so I don't need to circle anymore. Actually, I'll circle the first couple of ones, so just because I want to make sure. All right, so I've circled those two words. All right, so with that in mind, Coburn, out of those two words that I've circled, which one of those has the lower frequency? Microwaves, all right. Kevin, out of those two words that I have circled, which one of those has the shorter wavelength? All right, good. All right, so there's that one right there. Let me go ahead and erase. Let me do another one here. Let's just do straight here and here. All right. So we got circled infrared and X-rays. All right. So Jasmine, infrared and X-rays. Out of those two options, which one of those has the what did I ask you? Lower, Coburn? Okay. Which one of those has the higher frequency? All right, where do you see higher frequency? On what side of the diagram? All right, what side is that? There you go. And so which of the two words that I circled is to the right? So that be the one that has a higher frequency. All right, so that's the whole point of the arrows. The whole point of the arrows is to let you know which direction you should apply these concepts here. All right, let's do another one here. Victor, this one's going to have your name written all over it. So we got microwaves and we got x-rays. We got microwaves and we got x-rays. So Victor, my question to you is this. Out of those two words that I've circled, which one of those has the lower frequency? All right, microwaves. All right, Deshanti, which one of those has the shorter wavelength? You say microwaves? Huh? All right. All right, it's x-rays, okay, because it says right there in the arrow, shorter wavelength to the right. Okay, so again, we got to pay attention to the arrows, know what these connections are. All right, so now what I'm going to do is I'm just going to erase that right there. And now we're just going to just see what we can remember. What can we do? How can we connect the dots here? All right, so I'm not even going to circle words anymore. I'm just going to say the words. All right, I'm going to everybody. Probably going to everybody twice. I'm just going to start on my left side. Zyquez, microwaves, gamma rays. Do you see it? All right, which one has the lower frequency?
Microwave.
All right, good. Eric, radio waves, ultraviolet. Do you see it? All right, which one of those has a higher frequency? All right, Coburn, microwaves, infrared. Do you see it? Which one of those has a shorter wavelength? All right, Medevil, radio waves, ultraviolet. Do you see it? Which one of those has a lower frequency? What were the two words I gave you? And ultraviolet, and I said which one has a lower frequency? All right, it'd be radio waves. Because remember, longer wavelength, lower frequency. Okay, shorter wavelength, higher frequency. All right, Jayla, microwaves, gamma rays. Do you see it? Which one of those there has the higher frequency? Gamma rays, Mahomes, infrared, and x-rays. Do you see it? All right, which one of those has the lower frequency? Infrared. All right. Kevin, orange, blue. Do you see it? Which one of those has a higher frequency?
Orange.
Sure. Okay. It's blue. Because higher frequency is related to the shorter wavelength. All right. So remember, higher frequency is always going to be connected to that. All right. Lower frequency is always going to remember connected to that. Okay. So if you want to remember it a certain way, longer begins with what letter? L. Lower begins with what letter? So just remember, longer, lower, and then the other one's higher. Maybe that might help some of you. So remember that stuff, all right? Victor, let's go with microwaves and ultraviolet. Do you see it? All right, which one of those has a higher frequency?
Ultraviolet.
Good job. Alondra, you got orange and green. Orange and green. All right, which one of those has a lower frequency? Orange. Donovan, you have red and infrared. Red and infrared. Which one of those has the higher frequency?
High frequency, that'd be red.
That'd be red. All right, Jordan, you got violet and ultraviolet. Violet and ultraviolet. Which one of those has the shorter wavelength?
Ultraviolet.
Ultraviolet. All right, Deshanti, you have radio waves and yellow. Radio waves and yellow. All right, do you see it? Which one of those has the lower frequency?
Yellow.
Okay, it'd be radio waves because it's further left. Remember, yellow is going to be over here. So yellow's there, radio waves is here. Lower frequency is going to be to the left. If we get ready, literally you can't make it any easier than this. Longer begins with what letter? L. Lower begins with what letter? L. Left begins with what letter? All right, so basically, if you're on the left, you're lower, you're longer, whatever it is, that's what you are. So just connect all the L's. All right, where am I at? Jasmine, you are microwaves and ultraviolet. Oh, microwaves and ultraviolet. Do you see it? All right, which one of those has the lower frequency? Microwaves. Nate, you have infrared and ultraviolet. Do you see it? All right, which one of those there has the higher frequency?
Infrared.
Infrared?
No.
No?
Ultraviolet.
Ultraviolet? All right, you went 1 and 1. So what's your final answer?
Ultraviolet.
Ultraviolet? All right, ultraviolet's going to have the higher frequency. All right, infrared and ultraviolet there, Eric, which one's got a lower, which one's got a longer wavelength? Infrared, all right. And Jordan, orange and ultraviolet, which one of those has the higher frequency?
Orange.
Okay, ultraviolet.
Oh yeah, ultraviolet.
Okay, has the higher frequency. All right, Mahomes, X-rays and ultraviolet. Which one of those has the longer wavelength? Ultraviolet. Yep. All right, Medevil, blue and infrared. Blue and infrared. Which one of those has the higher frequency? Blue. That is correct. And Zyquez, microwaves and X-rays. Which one has the bigger wavelength? Microwaves. All right, there you go. So everybody's kind of gotten some questions here. Does everybody understand how to read the diagram? All right, remember, this is an example of an electromagnetic wave, and electromagnetic waves are created by electric fields and magnetic fields, but more importantly is they don't need a medium to travel through. All right, let's get some information real quick about the radio waves. All right, so radio waves are the ones that you are able to, like in your car, radio waves are the ones that send the signal through the air that reaches the antenna to your car, which allows you to hear music in your car. It also works for the television as well. All right, especially if you use an antenna, if you're not using cable, that's also radio waves. But also microwave ovens, they use radio waves. Microwaves are just the highest. They're the highest frequency of the radio waves. So radio waves are kind of category. All right, radio waves include AM and FM. Television waves include the ones that travel through the air that you have your antenna on top of your house or on top of the TV set, or satellite signals also use television waves as well. So I'm going to give you some time to write that down, and even though we're not done, this concludes the recording of this video.